Yes, I just started. Okay, so we'll start today. I'll show you a very powerful Python technique. So actually I buried it. I needed it for myself. So I buried it in the testing package. Okay. So you see what happens here is I have to do this test. Just look at, can you see my screen? Is a font big enough?
Yes.
Yeah. So you look at this code here, right? Just this def test, blah, blah, blah. This is a normal test function. Okay. Now, when I started writing this codeboard thing, I used to write a normal test function like this. And then for you, I would create some stub code, right? With everything is passed here, blank. So what happens is this test function will invoke that blank code when you hit submit. And what happens is, in some cases, the blank code will throw errors because this function will invoke something and it can cause errors. So when it causes errors, what it will do is just a whole program will crash. And when you hit submit, you won't get the right score, right? Because the program is trying to run each of these functions, get some output, and then give you a score for each answer. But if the whole thing crashes, it's not going to give a good score, right? So then I decided that I would put some exception handling. So what I have to do is I have to write this code like this, okay? So let me just now introduce as well the concept of exception handling. So the idea with exception handling in Python, very easy. You do a try block. Inside the try block, you do whatever code you think will work. And then you catch the exception with an except block, right? So you do this, okay? It's very similar to .NET syntax or whatever, or Java syntax. You catch the exception. It's a base class. If you have specialized exceptions, you can catch derived classes. Okay, it doesn't matter. But you just try something. If there's an error, you do the except part. In the except part, you do whatever it is to fix the problem. So in this discussion, I don't care what is done inside the except block. Just think of the structure, okay? But notice now, in order for this, so this will take care of my problem. But notice now, I have to put this try and except on every function, right? Everywhere I have to copy this thing out. Can you see it? I won't copy it again, but you can see it, right? Every time I write a test function, I had to write this code. Right? I had to put try, blah, 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 and then I copy paste this exception. Does that look like a good thing or a bad thing?
A bad thing, actually.
But did anybody ask you how to deal with exception? What do you do? If you have exception, I do try except, right?
Right.
Yeah, I can't do anything else. What do? Right, I have to catch the exception for each function. Okay, but now I'm going to show you Python magic, okay? So what is the Python magic? Python magic is, I can actually create what is called a decorator. I just put this little, it's like .NET attribute.
Your mic is, could it be a little louder? Volume be just a little.
Is it any better now?
No, it was suddenly better in between.
Yeah, I don't think it's the mic, but okay, I can give it some gain. Is it better now?
No, it's the same. Yeah, now it is better.
Yeah, okay, probably, okay. Okay, so what am I saying? I'll move a little closer to the mic as well. Okay, so what is the idea is that I create this little decorator, test with exception, okay? And this decorator will do all the equivalent work for me. How does that look like a plan first? Does it make my code cleaner or not? Oh.
Yeah, it looks like.
Kiran says she can't hear me. Can you not hear me, Kiran?
I can hear you very, at a very low volume.
Kiran, can you check your laptop volume?
Because it's okay for Sachin, right?
Yeah, it's good for me.
Okay, no problem.
Kiran, can you hear me?
I cannot hear you also properly. I'll bring a speaker. I think there's some problem.
Yeah. Okay. Okay. Give it a minute.
Okay.
Yeah. Go get your. Yeah. Go get your speed. So let me ask Sachin. What do you think? Is this a good improvement to what we had before?
Yes, definitely. It's like yeah, good.
So all the try except is gone, right?
Right, right,
But I have to now. How does this thing work, right?
right.
Okay. So first of all, the idea is this very interesting thing. This thing is called a decorator. Okay. Kiran's back. Kiran, let us know when you have the speakers up. I'm telling her, but she probably can't hear me.
Can you say something?
Yeah, something. She's smiling. She
You
heard me.
you may start now. I
Okay.
think it should be fine.
Okay, so Kiran, remember I erased the code that I wrote before with the try and exception. And I said, suppose I could create something like this, a little symbol. And
Yes.
wherever I want try exception to happen, I just put it next to the function which I want to have try exception. Do you think that's a better way to do it? If I could make it work?
Yes, I think it is better, but where is that exception? Test with exception.
No. I'm just go step by step. I do
So where
this.
is that catch thing, Vijay?
It's happening by magic for you. I give you guarantee that is already doing try and catch for you.
Yep, this is excellent.
Yeah,
Okay. So now the question is, how do we do it? Okay. And the concept here is, it's called, this is the bare function. This new thing is called a decorated function. Okay. So how do I make a decorated function? So the decorated function works by writing another function. Here, you see test with exception. It's another function. It takes any function as parameter. Okay. And inside this function, I do all the behaviors I want to change that function's behavior. So in particular, I actually do this here. You see, I do the try block here, then I execute the function and catch the exception. Okay, don't worry about this func tool wraps. When I do details, I'll explain. Okay, but I want you to understand this idea that the function execution, the original function I wanted to execute, is being executed here on this line. Okay, and then around this function, I put the try catch block. Now, what does Python do? When it comes here, it sees this test with exception and says, oh, I think you want to decorate a function. So then it jumps here and looks for the decorator. It realizes the decorator will accept the function as a parameter. It passes this function into that guy, and it gets executed in the context of the try except block. How does this look?
it's good. Yeah,
This is good, Vijay.
Okay, now let me give an example. Many of you in production setting might do this. You call a function and you want to log all the parameters coming to the function, or you want to log some messages when the function is getting called, right? Have you had a need like this somewhere? Any of you write some log messages?
yeah, we right.
Okay, so now imagine you could just put a decorator and say, please log this function. And the decorator automatically logs when the function was called at what time and all the parameters that were passed to it. And all you have to do to make that happen is to write your own little decorator. What do you think about that? How much code is gone for you?
Right, right.
Yeah. So we can write a lot of very clever code. And you can see my own example. When I finished writing this, I was happy, right? Because I took off all this try except stuff all over my code, and I just wrote one decorator and I'm done. Right? So I think the moral of that story was, there are a lot of powerful tools. We must first slowly know them and then practice them, and then we can be very productive. Okay.
Yes.
I think Pallavi is here. Sorry. Kiran, I'll put you in charge of greeting Pallavi.
Okay.
Reception committee. What happened?
Hi.
Hello. Hi.
Sorry.
No, don't be sorry. I put Kiran in charge of the reception committee, but she disappeared for a minute. I don't know what happened.
Okay.
Okay, so Pallavi, welcome. I know we missed you last time, but quickly, did you get to practice last time? Anything after last time?
Yes, but I've been doing the basics, the initial 1 and 2
Oh,
more. And I've
okay,
not yet gone to data series and data frame yet.
okay. So I know Sachin had said he would like to look at Lab 3 a little bit. So we could do that. If you have any quick questions on Lab 1, we can even look at that quickly. Or at least ask the question and then we can see.
Not right now. No.
Okay. What? Okay, so give me your impression. Something was hard, something was easy. What's going on?
So the thing is, I just feel that lab 1 and
Yeah.
2 were like, good stepping stones, but I still feel I'm not very, quick in them.
Okay.
And you have already seen my code, so I need to really brush up my algorithms and
Yeah.
program writing part.
Yes.
So I've started doing like I was finally able to download Anaconda and start practicing, and also I've started doing that
Okay.
on my laptop, and yeah, I hope to this next week. Within that, I plan to get to pandas and the panda library and do the data series and data frame part of it
Sure.
better.
Sure. So locally, are you running Jupyter notebooks?
Yes.
Okay. So that was easy setup and running everything was easy.
Yes, it was because we had seen Jupyter Notebook. If I had done this all first time, it would have been like a bouncer. But having done this particular course,
Yes.
everything seems a bit okay, familiar and easier. So
Yes. Yes.
yeah.
So okay. Let me ask you. Okay, give me 1 second while I figure this out. Uh, Actually, what can you see on the screen right now?
Trinket.
Okay, you can see. Okay, so I want to ask you this question. Let me see. Let me just get this. So let me ask you this. If it's helpful, you let me know. Then I can kind of permission you guys. So I created something here like this. It's can all of you quickly. So this is to give you a chance to practice writing Python code. I've created some set of simple problems.
Uh-huh.
Okay. So for
Okay.
example, this is a problem and you can write the solution right here, right? You can write the solution right here and submit it to me. If I gave you access to this, would you guys use it? Would it be interesting for you? And then I can review the solution and give you some feedback or whatever.
This will help. Yeah, Vijay. Yeah.
Okay. So there's about, I haven't finished this. I just started doing this. There's
This
about
will really be helpful. Yeah.
Okay, don't get frustrated if you can't do it though. Okay, just try.
No. Yeah, correct. But we are I'm struggling with two levels right now. One is thinking about the algorithm on one hand, then translating it into Python syntax. So both areas a little unfamiliar right now. So doing this will make that way it will be
Yes.
real hands-on on both those sides. Those
Yes.
simple algorithms that we had done 10, 15 years ago, but now coming back to them again and uh,
Yeah.
easing
Yeah.
our
Yeah. Something
dexterity.
like this, for example, is a nice problem, right? It's. I mean, this were some problems I did with Kiran when I did practical Python that's what I did. I tried to create problems like this, and we met and we solved them together, right? But if you want just to get started, I can share this, and then you can try and see if it's helping. Okay. But I agree with you, Pallavi. That is, in some short sequence, practicing language fundamentals, then practicing algorithms or some solving problems with algorithms will be very good foundation, right? Very helpful thing.
Correct.
Yeah. The problem is, I think the problem is you just trying to get a book and read it and work through it and all is going to be most people will never finish that project. Right? Because life happens, you get distracted, you do 3 chapters and then you stop, right? I mean,
Right.
so somehow, like we're meeting here, even if we miss one class or whatever, we still keep moving forward. So just spend some time, think about, okay, what is needed and then what is likely to stop that target from being achieved. You guys can discuss together, but don't be over optimistic or over pessimistic, okay? By over optimistic, I mean saying everything is easy, and over pessimistic is saying, oh, it's impossible, life is difficult, nothing will happen, right? Somewhere in between, a little progress is possible, but then collect the right approach, and then we can make progress. Okay, so much for that. So I will send, just if I don't send it, just send me a reminder, okay? I'll send you a link to this. You might have to create one login for this, okay? But it's where I have it. So I could transfer this into a Jupyter notebook, but right now I don't have the time to copy paste it. So I'll just leave it here and.
And whatever we do on this, it will be visible to you.
Yes. So if there's a dashboard here, I can see who's submitting.
Oh,
so I can see your code and then I can comment back, just like codeboard. Just like codeboard, but here, yeah, what I have on actually the course website, this is like a whole course. I have all the material instructions. It's like everything is here. Okay, so what am I doing? So today we're going to do lab 3, right? Isn't that what we wanted to do, Sachin?
Yeah, Vijay.
Okay, so what? So start me off with some questions. Ask some questions.
I haven't gone through the live exercise.
Okay.
Yeah, so I wanted to something, if others having questions, or we can revise the lab.
Yeah. So let me open it up anyway. Let's see what's in here.
PK, I have a question. I may forget, when we actually start on it. So just 1 or 2 questions I would have.
Yeah.
So in the Titanic data analysis,
yes,
where we have read the file,
yes,
that's titanic.csv is the file which we are reading.
Yes.
When I read the whole thing,
yes,
in a data frame,
yes,
I could actually see 3 data frames inside.
What?
I mean 3 tables inside in a single data frame. So when I try to do a DF.
Okay, I don't believe you, but okay. Sorry, I'm saying like this, but we'll go and do it. But let me do one thing first. Let's just open it up in Jupyter, okay? Because I think Sachin would want to discuss some fundamentals as well. So if you go to this interactive session, let's just open up the Jupyter notebook. I believe I have Titanic loaded up there. Let's see. So make sure you sign in. I don't think you need to reclone it, but just check if you need to. Okay, so I'm just starting the notebook, okay? And we'll go to Intro to Pandas.
Vijay, I do not want to recall all, revise all.
No. I will go straight to Titanic. Okay.
Yeah.
I understand what you're saying. Let's if you need to review something, we'll review it. But otherwise, we'll go and do the lab.
Yeah.
So okay. So if you all open up this notebook, I believe at the bottom I put Titanic stuff, but I don't know if you had time to discuss it enough, right? So I can get there, and then we can just see what happened. Yeah, here it. No, not yet. Okay. By the way, do you guys see the power of Jupyter now? I can put like nice picture inside there and everything, right? And so I can make a nice looking document. Okay. So yes, so here right now I just loaded up the data. Okay. So Kiran, this is the code, right? Oops, I have to import pandas. Okay, so this is the code. So how did you see, or you think you saw more than one data frame or whatever?
Yeah.
What was the code you ran? Did it look like this or no?
I think it didn't look exactly like this. Vijay, if you could,
Yeah.
could you put in my code also along with this? Is it possible? It is inside the lab.
Okay, so you submitted it?
Yeah, I have submitted.
Okay, give me 1 second to find it, okay? Um, lab 3. Sorry. Okay. Okay, so Titanic, right? Yeah. So your code looks like this. Then you wrote this check file, did you? This is what you did?
Yes, yes, yeah.
Okay, and then what did you where did you put it in test or did you put it in main?
In main.
Okay. So what is in main?
It's my
Where,
check file.
where? Okay, let me just make it a little bigger so everyone can see it. Okay, so where in main is it?
There's a ta.get check file
So let me just try to.
in the last fourth statement.
Yeah. Let me just comment out this part.
Will be the last fourth.
Okay, so ta.getShape. Okay, so let me just run this for now. Let's see what happens. Okay, I don't know, some errors there at the bottom, but
Maybe
okay.
you can I think you can comment the last 3 prints also, and then there won't be any issue, because
Okay.
that was that I was still trying.
The last 3?
The last 3, yeah, comment these.
Okay.
Yes, now you can run.
Okay,
Yes.
so you ran something. Okay, now?
So here I see 3 tables, Vijay.
Why do you see 3 tables?
The data frame from Titanic contains, and then I
No,
when I did,
why do you see, how do you see 3 tables?
so one is the passenger
So
survived.
one thing, okay, I will always insist on this. It's called the principle of least surprise. The principle of least surprise says pandas load CSV. If you load one CSV, you get only one data frame, right? It would be very strange if one CSV becomes 3 data frames. Yes? Agree or
But
disagree?
it's all just, yeah, but it's all
No, stay with me. I'm trying to do something very tricky. I'm trying to change the way your mind is working, which is hard, okay? And I'm trying to make a joke out of it. But there's something important here. If you follow the principle of least surprise, it will save you some pain. So the principle of least surprise right now, I'm using it and I'm saying, if you load one CSV, is there anyone who expects more than one data frame in this group? It's one tabular data structure. If I load it, what should I get? One data frame or more than one data frame?
one data frame.
One data frame. Okay. So we are convinced this is, if anybody gives me more than one data frame, I would think that's a crazy library. I wouldn't use it. Right? Because like it doesn't make any sense. Okay. So now that is where my mind is anchored. So now I come here and I'm going the way Kiran has written this code. I'm just going here and I'm saying, okay, Kiran, you wrote this code. I ran it. It gives some output. And yes, it looks like 3 tables. But could it be that it is a display problem?
Vijay, it could be a display
It
problem.
could be a display problem. Now,
Because
stay with me. Stay with me. I'll show you where the clue is. The clue is there's a slash here. And the slash is saying he's cutting it because it's not fitting and he's displaying. Right, that's all it is. It's just a view issue. It's nothing to do with what's in memory. Okay, and even better, I'm saying that here in check file. So sorry, did my detour make any sense to you? Like we have
Yeah,
to
Vijay,
keep.
it makes complete sense because in TA.shape also, when I checked the shape, it showed 12 fields or 12 columns.
Yeah, so this is the right. No, it says it's 891 rows and 12 columns. Yes.
Yeah, so 12 columns, and those 12 columns were not visible in a data frame. Maybe because
no, it's visible.
Not maybe, but sure. Display problem was there, so it was split into 3 separate tables.
Correct.
Only for the display purposes.
And that's why I'm saying. So now we can go back here. That's why I opened up this. See, codeboard is okay. Codeboard is actually doing what raw Python would do. If you put Python and you print it to command line, you'll see this kind of behavior. Jupyter is doing a little better formatted outputs for us, right?
Okay.
So if let's take your code. Let's just take from codeboard this one. And then we can go back here and let's just put it here. So this is another thing you can do, right? I mean, I think Sachin is doing this right now. I don't know what you suit yourself. Sachin is writing a lot of his code, I think, in Jupyter and then copy pasting it into codeboard.
Yeah, I'm doing that.
Yeah,
Whenever I write code, I always do it on Jupyter actually first, and then I place it there.
Yeah, we want both.
How does it help you, Sachin? How does it help you? Because I do both things separately. The ones that are written here, I do it once.
Yes, Jupyter has a good display actually. So yeah, I can compare. I can see the data actually in a more systematic way actually.
Yeah. Okay. So anyway, so let me run. What about Pallavi? What would you do?
No, I keep doing the run and see in the code board. Initial lab one, I did do it in Jupyter and then come back to code board. I was not yet clear on code board, but lab 2, I mostly did it on code board itself.
Yes.
No, I didn't come back to Jupyter.
Yes. But also, Pallavi, last time I discussed with the group, okay, on code board, what is important in code board at the end of the day is all the tests in code board is very important. I think I convinced Kiran and Sachin last time that the testing is very useful.
Yes.
But I didn't convince you. So you can either come back to me and I will convince you, or you can ask them, they will convince you. Okay. So, but anyway.
I have my only 3 of them passing and rest of them don't yet.
No, I know. But I'm saying that how to write tests and use tests and use tests to guide your development. Okay. And I'm saying your Scrum Master right now, actually in an agile team, the developer himself would write the tests because you don't have a separate QA team and all that. But even today as a Scrum Master, imagine you could just take the requirements document and write a few tests and tell the team, you pass my tests and then we can consider the sprint is finished. Right?
TDD.
So that is, well, TDD is even more powerful, right? It's powerful or not, but it's a whole discussion. We can have a separate discussion on this because it's very foundational.
Yeah.
So let me just say to all of you, there are ideas and then there are thought patterns. When the ideas change your thought patterns, that is very useful. So testing is one such thing. It's an idea, okay, you should test your code. But it's not changing the way we think about how we write code. And some bright guy came and said, write the test first. Don't even write the code, just write the test. And then you can write the code afterwards. Now, this is an easy thing to say, but people don't think like this all the time. Right? So we never ask. In fact, we never ask. You can try it with something in your life. Something little abstract, okay? Like if I say, how will I test my chapati? Then you know what to do. I'll eat it when it's ready, right? But if it's more complicated, right? So I don't know, you're fermenting dosa flour or something. How will I check if it's ready or not? It's hard, right? Because if you make the dosa, then it's maybe too late or too early, whatever. So how to write good tests is not easy. Therefore, how do I do TDD first? Like, Sachin has some complicated ETL project and then somebody says to him, write the test first. He's like, what test will I write? It's some complicated thing. right? So we don't, until you train like this, we don't see the tests immediately. That's why this is good practice for all of you, right? Then I'm giving you some tests up front. You should look at those tests and see if you would write them naturally yourself, right? So first, don't look at my tests. Just say, okay, pretend I'm trying to do some test first development. What test? So read the question. So this is the protocol, right? Read the question. Let's just go back to the question page. Let me just open up one question. So read the question carefully, then say what test could I write. Okay, so let's do the Titanic one. Compute the shape of the data in the data frame. Right? So now very interesting one. How will I write the test? So let's spend a minute trying to answer this question. How do you write the test for this?
What do we mean by shape of the data? Like how many rows and columns?
Yes, how many rows?
Okay.
So how would you write this test?
I'll have to open the CSV and know the row and column, write the test with,
So that is one. Well, so this is why I said we must think like this. Now I'll tell you immediately. If you ask me how will I write this, I would think for a minute, and then I would say no, I won't open the CSV because that test saying. So what is the function? So this is what I said. The thinking process here is very important. So let's go and look at the function here, which I've given you as function stub. The function stub says get shape, right? And it takes a data frame, and then it returns the shape of the data frame. Okay. This should work for any data frame. So what I would do, so let's go and do this quickly.
I'll make my own data frame and pass.
There you go. You make a data frame with 2 rows and 3 columns or something. Then you write the test, you pass it. Then you do the Titanic dataset. Make sense? And if you really want to be a careful tester, you go to Excel or something, you open it, you count the rows and columns, and then you put it in your test. Okay? That last part I have actually, in this case, that's why I said this is very helpful work for you. All that has been taken care of for you, right? So if you go here, I've already done all that. Right?
Correct.
The only point is before you do my test, maybe you should go through the process of asking what is the right test. Maybe you should make your own data frame, right? All these things, and then come to the real test. And really go through that process, says, okay, how will I know my code is correct? Right? And that is helpful. So I'm not sold on TDD and all that. You have to try it for a little while, then we should have a discussion. Then we will know. Okay, then only the insight will come. Okay, otherwise we're just, it's like some party slogan. We're just repeating something. Okay, does that make sense, Sachin, Kiran?
Yes.
Yeah, Vijay.
Yeah. So, okay, so now let's come back here. Okay, just one more thing since I'm on codeboard. Let me show you something. By the way, it's maybe not visible to all of you in the beginning, but actually there is some good stuff here in codeboard that I did to make the whole thing work for you. And let me highlight a couple of examples. So if you look at Titanic, for example, one of the things is you have to read a file, you have to load it, and then every function that we want to use, you have to load the particular data frame, right? Does that make sense? So what do I have to do in that case? What I have to do is, what I've done here is a very powerful Python, another powerful Python idea, right? When you make a function, a parameter can always be given a default value. So anybody, if you look at this code, this is where I'm puzzled that you guys are carefully reading the code or not. If I saw code like this, I'll be like, Vijay, what the hell is df equals df mean? Okay, but okay, now let me tell. Sorry, Kiran. Sorry, Kiran, you broke up. You have to come a little closer and say again. Oh, we can't hear you.
Can you hear me now?
Yeah, when you're very close like that, yes.
Oh, I was telling that, can you hear me?
Yes,
Yes.
better, much better.
Okay. when I looked at the code for the first time, I felt that this df thing is very odd. Why is it being passed as a parameter? I removed it for some time. It didn't work. Then I placed it back. So then I understood that this is being passed, and default value df has been provided.
Okay. So sorry, I have to say this because it's a funny story. You guys might appreciate. It's from my life in India. When I was in first standard or second standard, there was a story like, there we have English textbook. In an English textbook, there was a story. There was a king, and he found that people were not, exploring and asking questions and looking at stuff, whatever. They were not. They were just minding their business. So the story was about how the king went one day in the night with his minister, and they took a big rock, and they put it in the middle of the street, and they put some gold jewels under the rock, and left it in the middle of the street. And the people were just going around the rock, right? Nobody was looking to move the rock and clear up the street. And then finally, after a day or two or a week or whatever, the king comes and says, okay, I'm going to move the rock. And then he moves the rock and says, see, anybody could have got the jewels. It's sitting right there. Okay, so then, like how in India they used to teach us, they'll say, what is the moral of the story? Then we have to write some answer, the moral of the, okay, anyway, so this is the same thing. There's a rock here, there's some jewels inside it. Only if you move the rock, you're going to find out what the jewels are doing, okay? So what is the jewel here? The jewel here is actually interesting. df on the left-hand side is a parameter. So let me show you this quickly in Jupyter. So if I go here, so the idea is that whenever you make a function, right? So let's def a function called square, takes a parameter. Whenever you make a function like this, so let's say, whenever you make a function like this, right? So we can say, whenever you make a function like this, you have the option of setting a value for this. So you can just say this. Okay, it's a default parameter, it's a default setting, right? And if you set a default setting, then I can actually invoke the function like this. Okay, it will automatically initialize this variable. So now let's go and think about what was done there. What was done there is, you see here, def check this guy. I need to have a code here that says df equals something. Once df equals something is there, it will automatically put the df for you. So I did all this extra work, so now you can actually just do the code. You don't have to worry about loading the data frame. Yes? And I think I put something in the instructions. Let's see what I said. I don't know. Okay, I didn't particularly say, maybe somewhere I would have said.
Yeah. Data frame for all the analysis in this section, the default value for all function has been already set to this data frame.
See, the jewels are there, Kiran. The stone is little big. Right? The rock is little big. But I think it's very important for me to share to all of you that at least to get maximum benefit, right? I put a lot of time thinking how to, for my own world, how to organize my code properly. Hopefully you see a little bit of that discipline when you look at my code. If you don't see it, you should come back and tell me, Vijay, your code sucks. What is all this, right? Because I want to get better, of course, right? Maybe you can do it a little more kindly than what I said, but okay, you can just tell me. But my point is, yes, you can learn some things even if I'm not explaining by just looking, how is this done? And then if you don't understand, you can ask me and then I can explain in more detail. So anyway, that is the reason I took this detour is to show you something quite powerful, and of course we're going to use it, right? So okay, so we did this check file thing. Now here, what was it? No, get check file. We need the other function, right? What was your function? Yeah, it was get check file. Yeah. So if I run it here, you see the out. Let's see if the output is here. There you go. And you see the display is whatever. Now Jupyter will display, like the columns and so on, right? Makes sense? Now I have to ask you this. What was in your mind when you wrote this particular code? Did you want a data frame back? Or it didn't occur to you the data frame was already in DF? You didn't have to really, Or you were trying to check if my function actually works properly?
I'm quite used to that. So unless I see all the results there, I don't go for this.
Okay.
So I was trying to print everything in my main to see
Yeah.
whether DF has something or whether it is what the file exactly contains.
Good.
The old way of debugging. I do that too.
Yes, you can do that. Yeah, no problem at all. Whatever works is fine. Okay, I won't spend more time on it. So now, okay, so we started. First part of the assignment was get shape. Okay, so now we've done that, right? So that was easy. So we could have just said df.shape. That was the only question. The idea was, sorry. Oops. The shape is not a tuple. It's just a property. So I don't have a function called. Okay, so rows and columns. Okay. Kiran, while we are here, I will just ask you. You asked me a couple of times, how do I get the? I think it was from a previous class. How do I get the rows and columns in the database, etc.? All that, right?
No, Vijay, I haven't got that. You said some cursor code, but I was not able to place it properly in the code so that I could see those values. But when when I did a read CSV, I could see the columns also along with the data values. So I was very happy that at least column names are coming. Otherwise, in my previous code, I have used those column numbers 1, 2, 3 column indexes 1, 2, 3 to find the maximum or to find unique values of a particular column.
Right. Okay, so it's a small switch for us to go to database code, right? So I won't go there right now. We'll finish this and then once we do something. Okay. So the point I want you to know is that if you are running any data set, once you load it, you can say df.shape and you can say df.info. Okay, and info gives you a lot more information, right? Because info tells you what are the columns, it tells you they are integers or not. It gives you a lot more information. Okay, and actually what is quite useful also is it tells you what the memory usage is. Right, which is very cool. In many languages, to find out that information, you have to do a lot of work. Right, you have to go write some things. I don't even know. Like I can ask Sachin, in your Power Builder, you load some array, you want to know how much memory is used. Can you find out easily?
No.
Yeah. So here it's visible all the time. So when you load a data set, you should be quick to see. Quick to see what happens. Okay, now just while I'm here, I need this later for visualization. Let me see if I can show you this thing. So many of the libraries, even pandas, but I use this library for visualization. I just played with it this morning. It's called Seaborn. Okay, SCABORN. And usually when we import things, we give it a name. The industry has a standard name to keep these things. Seaborn is called SNS. Pandas is called PD. Okay. So now I can say Seaborn actually has Titanic in it. Okay, Titanic equals SNS dot, I think it's called load dataset. I think this should just work. Let me see. So what it does is Seaborn has put a Titanic dataset in the cloud somewhere, and this will go over the cloud, over the network, and pull the dataset for you. You don't have to use it. I'm going to change this in a second. Okay. So there are a bunch of data sets. So for example, just to prove to you that it actually came back, let's just check it out. So the first thing you do is you do Titanic dot shape. I know what it is, so let me just do info for now. Right? So I want you guys to get used to this idea that if things are set up correctly, we can be very powerful. In one line, I grabbed a data set, I can start doing some analysis on it, right? But you must know where to look for things and what the data set means. So later for visualization, I can use some of these data sets. So just to show you how easy it is, there's another data set here. It's called iris. How many of you like flowers?
I like
Anyone? Huh?
flowers.
Flowers.
Yeah, I like plants in general.
Okay, so, and how many of you like biology or botany?
Botany, okay, not not the human part. Zoology, I don't like.
Okay, we'll discuss that another day. It's a big topic. Okay, but I wanted to just say this is a very classic data set. Okay, it's called iris data set. Later, I can even show you some pictures and so on. I don't know if you've seen iris flowers. You can Google and see some images. Quite pretty. Actually, I have some in my garden right now. Maybe I can send pictures. But anyway, so iris is pretty. This became a data science problem because if you look at this, so everybody knows what a petal is, right? Does anybody know or remember what a sepal is?
The green part below.
Yes, the green part below.
Right.
So the idea is this data set has 3 different species in it, 3 different types of iris flowers. Okay, like iris, the species has a name, iris setosa, iris virginica. There are 3 different species in the data set. And for that species, they have taken some sample flowers and they have measured the petal length and petal width, the sepal length and sepal width. The data science problem is, can you separate this? If I give you now a new measurement of those 4 parameters, can you tell me which species it belongs to? Can you predict the species given these data? Right? Make sense? It's a good example of what's called a classification problem. Right? There are 3 classes. Then I give you some data and you have to predict which class it falls into. Okay, so we're not yet doing data science, but okay, already I'm just showing you how the data works. And I use this as an example quickly to show you that later we can, when we do more Python, when we do the practical data management, we can actually pull these data sets and then try to look at it at least. Like, how does this look? How many data points are there? What is the information? What is the distribution of lengths, etc. Okay. But there are many data sets available like this. So if this is working well, a modern data science story should look like this. Very quickly, the problem I'll tell you, of course, is like I explained to you what is iris, what is petal, sepal, why this problem is interesting. That information is hard to find. Right, so you'll get some data and then what am I supposed to do with this, right? If I showed you this without telling you the story, you'll be like, okay, there's some numbers here, what will I do with it? So for example, if you just say df, if you say df, yeah, you get something like this, right? What are we going to do with this? Right? So yeah, you can play around. So I'm doing all this just to get you familiar with pandas. By the way, can I tell you one more thing? This is I don't know if it's a good thing or a bad thing, but pandas normally when you want to get a column, you have to put the column like this. You put a square bracket and you have to pass the column name as a string, right? You have to do this. If I want to see the species, and really what I wanted to do is I wanted to know how many species are there. Spelling. There you go. Right, 3 species are there. So this is a normal syntax that I've shown you so far. Column names are specified with string. But actually, because we use columns so often, pandas allows you to do this. df dot, and you can hit tab even.
Attribute.
And it's going to work. It's kind of cool. The only problem is there is a discrepancy in the API that column names can have spaces in them. Right? You can say, for example, let's look at this. Sepal length could not have an underscore in it. Okay, it can have a space. As a string, it can have a space in it. But if you use it as an attribute, you cannot have a space in an attribute. So I don't know, but in general, because I'm working with all kinds of data sets, I don't use attributes. I just use strings, so my code is consistent. But like these guys have done, they have fixed the problem. They've given you column names with no spaces in them. So then you can use it like this. I don't know. Think about it and see, pick a pattern and work on it. But okay, have I convinced you all that quickly getting a data set, running info on it, establishing some basis to think about the data set is a good start? Yeah? Everybody's comfortable now? Any data frame you're ready to work on? Okay, so let me try an experiment. So there's a nice data set here. It's called tips. Okay, so let's see what tips is telling. Okay, so the task for you is to look at these columns and tell me what you think it's doing.
Total bill tip. Okay. So this is like at a hotel. What kind of tips are given by whom at what day time,
Exactly.
and like yeah,
Exactly.
whether they're smoker or not, or male or female.
And the goal is to try to predict the tip if I give you these parameters.
And that part I know you're going to take it in the next course, okay? But it's that is where I'm like, are we using statistics? What is it like? What does machine learning do that you keep feeding data set to it and then it's like starts predicting this and that?
It's
That's
not,
that.
it's not that complicated. Actually, I gave Kiran a little version of this. But yes, we can do this soon. It's not too hard. I mean, to get you started is not too hard. To become an expert,
You start thinking like that, start thinking like, what can I do with this data now? What is it? What is the answer that I can get out of it?
but of course, what I'm showing you also is that, see, this problem now is, to take all this data. For example, you see here already, these are what does category here mean? How to organize this, how to use this. There's little work from a data management perspective. What has been done right now is it has been easy for us to at least load it. So that is an interesting one. At least the loading problem has been reduced to 1 or 2 lines, right? So that for ETL guy like Sachin, that's already a big deal, right, Sachin?
Of course, actually, and yeah, minus the data is always a big thing for the ETL.
Yeah, and people mess up the data a lot. I can give you many examples, right? So here at least, so that's what I'm saying. It's a mixed bag. Okay, later when I ask you to go out in the world and get me real data without using these kind of data stores, you're going to have a lot of extra work. Okay, so anyway, so we got the data. So now let's go back. Let me go back and just load up my what is it called? Let me load up my Titanic again, and let's look at the next question maybe. Did everybody take a second and look at this? Okay, so I guess we should do df.info on it quickly. Okay, so does everybody understand what the columns mean? So this, I'm just telling, this is all before I do the lab, this is all work you should do. Okay, so what is the columns mean?
Yes, this you explained it that day.
Yeah.
When we had data frames.
Okay, so everyone remembers or whatever, you just refresh. I've given it in English here. Okay, so just, okay. Okay, so now what is the lab asking us to do? Write a function, get distinct values, column name. Okay, for any column name, you should get the distinct values. How will you do this?
Just now you showed .unique.
Okay. You're at least watching carefully. Okay, so you got one assignment done, yes?
Yes.
Okay, and how will you test it?
Okay. So I have to pass one list. List is the right.
No, pass one data frame, right?
One data frame. Okay, one data frame with some two columns or something like that, and then kind of know what are the unique values in that and try to it should pass that one.
Excellent. So what I'm saying is, you see that if you go like this, you will not get stuck in some place and like what is happening, right? Because you're going, every step is controlled by you. You know what is going in, you know the columns, blah, blah, blah. If you take it and put it on the Titanic data set and you don't know Titanic, something strange happens, then you have to figure out backwards and come backwards and backwards to find the answer. Okay, so either way, just be, I like this. I like the disciplined way of doing it. In fact, for me, I have large sample data frames that I create by myself every time I want to practice something, right? Make sure that I've tested, I understand how it's working, and then I go and apply it. Okay, so we got that. So next question. See, my questions are too easy, right?
After you have explained the answer, it becomes easy, not before.
I see. It's a time-dependent thing. By the way, I will tell this, okay? I will tell this. I don't know what's the solution for it. sometimes when I teach the class, I explain that when you're working with me, I feel confident to say that there is nothing that I'm going to show you that's difficult. Okay, but when I leave the room, it will become hard again.
Correct. Totally true, because you make it look so easy, but till I put the code in code board and just see it run,
Yes.
it's not the same. It's like
Yeah.
looking at what you're doing. Yeah.
Yeah.
Because each underscore and each hyphen and each dot becomes difficult at that point of time.
Yes. But it's not my desire to make it hard for you. My desire is to make it easy, but I don't have a silver bullet, right? This is where we have to work together. I have to push some things and you have to pull some things. You'll stop me and direct me, right? I want you guys to be more articulate. If something is too easy, don't say it's too easy. If it's too hard, it's too hard, whatever. And just get me find the right spot. Okay, so the next one is easy. Okay, find survival probability. So what is that? So who feels comfortable with survival probability?
Survival probability.
So let's not write any code first. We have to ask what does it mean survival?
So number of people who survived upon the number of total people.
Okay.
That is the percentage of survival. Probability. Okay.
So what's the difference between percent?
Basically, same what you said, just in percentage.
So I feel so tempted to teach a whole class on probability, but okay.
Yes. Are you also taking a maths class? I'm attending that because my basics of maths are like all shaken right now.
Honestly,
I remember probability before, but not now.
Honestly, Pallavi, I'm saying to three of you, first of all, you guys work well together. I really love the energy in the room, right? You're all interested and want to learn something. So do the following, just think about it, make a list and come back to me and give me some ideas. I can do some sessions for you guys on any of those topics. Because you have chosen it, you'll be interested in it and you'll absorb it quickly. Right? I think actually probability is such an example. Actually, I was teaching a kid recently and I was remembering that when I learned probability and combinatorics and all these things, right? 3 yellow balls, 1 red ball, 1 green ball. I pull them out, I put them back, then you calculate some probability of finding something, right? And it used to drive me nuts. Because I was like, what are you trying to do? Why am I wasting my time with all these red balls and yellow balls? I'm not interested in them, right? I didn't appreciate it. And what happened is it was a problem for me later and later and later. It was just building up as a problem. But I promise you that if we go back to the start and we say, actually the world we live in many ways is more probabilistic than it is deterministic. There's a lot of things that we cannot know for sure. So we need a language to talk about things that are unsure. How do we set up this language? What is the structure here, right? And we have to start by saying probability, etc. So that conversation is actually extremely beautiful. And actually, surprisingly, it is very short. The axioms of probability are only 3. So very, very simple, right? And then we can do some problems and then you leave saying, wow, this is cool, I want to do more. So it's simple, but then of course, like everything I show you, eventually there's a complicated story at the end. Okay, so start thinking about this. Sachin just posted me something, so I'm going to just read it. And then we can solve this problem.
So we just start about 835 or 270, any unstructured file actually, yeah.
Yeah, okay. No, so let me, can you do me one help, Sachin? Just send me an email, okay?
Okay.
We'll pick up this thread on email because it's helpful for you. But
Okay.
let me explain some things here, which is very important. I'm just showing you how do we solve these problems. So the idea is that the actual algorithmic approach to parsing something is to build a parser.
That we do actually, yeah.
Huh?
That's what we are doing actually in writing a parser in DT, data transformation, to process.
No, but there is a so it turns out that the field of parser is extremely well studied. Right? Extremely well studied. What exactly does parsing mean? And how can I write parsing correctly? And in particular, how can I teach the parser what to expect? So actually what happens is it's very much like language. There is a grammar and you must be able to encode the grammar correctly.
Right.
If you give the grammar to a parser, it will do the job for you immediately. Okay, that is the long answer.
Yeah.
And me personally, I'm not a parser expert, but I would love to have some examples to play with and write some code. So there's a lot of infrastructure in Python for parsers. Okay, there's cool stuff that can be done. But we don't have to go this far. Typically, what is done on a file is you parse it line by line. Right? You go line by line. That's the first structure in a file. Is a data structure which is line by line. Python has simple read line function. But now the question is, what do I do with the line? And the answer is each line, you will basically try to break it up into its subcomponents.
Correct. Yeah.
So this is called tokenization. It's part of the parser structure. So you have to break it up into tokens. And the simplest but complicated thing is you use regular expressions to create tokens. Okay, so now I have to ask all of you, because I wrote this 6 months ago and I didn't have anyone want to study regular expressions, so I stopped halfway through. It is really a very powerful tool to write regular expressions. But it is a specialized language, okay? It's like SQL. Very, very powerful thing. It can take any unstructured text and break it up into sensible tokens. Extremely powerful, okay? You can ask for all kinds of, for example, if you have a news article and you want to pick out emails from it, you can just pass the file to it and say, get all the emails from this file, right? It will go find the emails for you. Now, if you write that in code, you can see that's impossible. This is why parsing files is nuisance. If you don't think about it correctly, you're going to go line by line, then you're going to search for www or whatever, and then you're going to, whatever, @ or something, and then you're going to get lost. Your code is going to be very complicated. But if you write it correctly, it'll be like 3 lines of code. Okay. But in order to use this powerful beast, you'll spend a few days on regular expression. If you're interested, then I can show you. So think of it top down, right? What are we trying to do? What are the structures we need? What are the tools we need? Then do we know those tools well? And then everything becomes easy. Makes sense? So, yeah. So if you guys want, yes, that's at least 1 or 2 sessions, I would say, if you want to do regular expression properly. Okay, at the end of that, you should be able to break up any text and extract what you want from it. Okay, and then it will be just simple code. It will be very, very straightforward.
Okay.
Okay. But for now, yes, you can use pandas at least, and you can get it if it's, you get into columns and so on, if it's that kind of data. It depends which kind of data it is. So we'll just follow up the thread on email. I'll ask for some examples.
Yeah. Okay, sure.
Does that answer your question though?
Yes, yeah.
Okay, so survival probability, what are we doing? Who's going to give the answer?
So number of survived upon the total number of records.
Okay, so let me just, sorry, Pallavi, we talked about this. You said percentage and probability. So the idea is this. I'll just make something, I'm not being precise here, but just for you to understand. Probabilities are basically a ratio. The ratio is, you first have to define what is called an event. Okay, so the event here is that you survived. Okay, the event can be that you're male and survived. An event is a structure that picks a subset. But a subset of what? Subset of what is called a sample space. That means everything. Right? So you see that if I take an event, which is a subset of the sample space, and divide by the sample space, then I will get a number which lies between 0 and 1. That's a percentage. But that is the probability. That is the definition of probability. The probability, so now I can tell you the math. The probability of event A is the number of elements in that event divided by the number of elements in the sample space. That is the definition of probability. So now that's what we got to get. We got to get the number of elements in the set of people who survived divided by the total. So how do we get the number of people who survived? Kiran. Kiran already wrote something. Did you write the answer or what?
Oh, we tried. I didn't attempt this one.
Okay, you were playing with it. Yes, I can see you playing. Okay, so how do we do this?
So df of survived is equal to 1.
Okay, so here's the thing, right? I left some blank space here. Okay. So we got DF. So how do we first, let's see, how can we count the survived people, right? And remember, this is where we're going to use the Boolean indexing here, right? So first we have to say, okay, what does it mean to survive? That means your survived parameter, DF of survived. What is the survived parameter? What is the, let's see, DF survived dot unique. Let's just see how it's stored first. So it's zeros and ones, right? So then we want to know if you survive. Let's say 1 is survived and 0 is died. So we'll say equals 1, right?
Equals 1.
We should double check that 1 is survived, okay? But let's assume it makes sense. So this will give me a Boolean array, right? False and true. But we know we can index with this Boolean array. So I will just do df survived equals 1. What will this give me?
It will give all the true values.
Yes. And for each true value, what will it return?
1. Number 1. Because value of true is 1.
Yeah. Yes.
Okay. So
in case of survived.
Okay. So let me run it. So.
Are you full? Sorry. It will give the entire data frame. Sorry.
Yeah. It will give the whole data.
All the rows. Yeah. Where it was 1. Okay.
It takes a second to get used to it, but of course, right? So if you pass a Boolean array, it's a filter on the data frame. So data frame comes back, but a subset of the whole data frame. If you want a column now, how will I get the column? That's easy. I can just do dot survive, right?
Dot survive.
Or bracket survive. Let me do bracket.
Okay?
So I can just do bracket here and say survive. Oh, sorry. So let's see what happens here.
Okay.
Okay. So this gives me ones wherever they survive. No zeros in there, right? If you're not sure of this process, we can do dot unique, but I'm sure on it, so I won't even worry. So I can just do now. What can I do here?
Sum.
I can do sum. Right? 342. 342 survived. Okay. Now I'm going to teach you a trick here. It's kind of a bad trick, but I think this trick is also making sense. Because the values are 0 and 1, I don't even have to filter out the ones. I can just sum it over the whole thing. Only the ones are going to contribute anyway. Right?
Correct, yeah.
So I can just do df bracket survived and sum it.
True.
Yeah? So that's even better. The code is less. So now what I have to divide by?
That's some like length of the entire DF.
So how are we going to get the length of the df?
The rows. Number of rows.
So how do we get rows?
TF dot count, Vijay.
Let's see. Doesn't work.
No, DF dot length. LEN.
df.len, is there a len like that? By the way, just so you know, len is a very powerful function in Python. I don't have time today to talk to you about how len works, but len, think about it, it's a function, it's an overloaded function. It works on all kinds of structures. You can ask what is the len of a dictionary, what is the len of a list, len of anything. But we can ask, is there an len for df?
Yes.
And it looks like Pallav is happy, len works. Okay, so yes. So again, I say principle of least surprise. When the language breaks these kind of contracts, it means somebody didn't do the right thing, right? The person who wrote pandas was supposed to make sure that len works on df, and he did do the right thing. Okay, and we are Python programmers. If somebody says what is the way to find the length of anything, len should be the right way, but not df.len, len of df.
Okay.
So now, yeah, so just divide this and you got a number. Happy? What is this? Now, is this cool or what?
Yes. It's a single line.
And was this too easy or what?
After you took us through it again, like, you know, it takes some reminding. So as you said, if you practice, it becomes easier, but till then it is It is just like having to go back to Jupyter and again see, having to go back to Jupyter and see.
Yes. I want you to reflect on one thing quickly though. The question which I don't know the answer to is, and that's why I said to you, when I leave you alone and say, go home and work on it, something happens. I am not in your head. But at least maybe you will learn if we have a session like this and we just work on it, right? At least you see it, you feel comfortable. Now, if I say, can you please go and type it in codeboard, maybe you can do it
Right away, I should do.
having right away or after, I don't know, okay? It depends how quickly it decays. But so my question to you, quickly give me feedback. Is this helpful? Do you think you'll learn better like this, or you learn like this good?
I feel, Vijay, it will be like, even better, like the way you showed the trinket part, right? Where we actually do it, because that is, that, till then it is not the same, because you
Yeah.
would have taken us through this. But
Yeah.
till I do it, it's still not the same.
No,
I have
but right now the codeboard is waiting for you to do it, right? Or you want to
correct.
do it while I'm talking?
Like while you're talking, or we are able to get your inputs on what we have done.
Okay.
Like now you make us do it, and now kind of like, so maybe when we meet next time, you're saying like, this is what you would have done, and I will check it during the session,
Yeah.
kind of a thing, and see
Yeah,
whether
like
we have
kind of like
gone
I
wrong.
did with Kiran's code right now, right? We pulled it up and we said, okay.
Correct, exactly, yes.
Yeah.
Vijay, that helps better, that we have done it a little bit, maybe, or maybe more than 50% of it, and then we are discussing, and then you're going back and correcting the code.
Yeah.
That helps better. But while you tell and we also write the code, I think that is difficult to do, because all three of us will be writing 3 different codes. Some may follow, some may not follow, and then focusing on the screen as well as on my own code board, or the
No, I think what has to happen is that I can slow down the speed, right? I mean, I can have a book or something and I can read something, give it 10 minutes, do the work, and then we can discuss. My reason for saying this is, if I leave you, say, go home and do it, then the number of hours of work outside this is getting close to zero, right?
No, it is not zero.
No, this week I really worked, Vijay, really. But not lab 3, but I did work on Python very.
No, this is good. This is good. I'm not trying to find fault with anything. I'm just trying to say,
No, it totally makes sense.
Yeah.
What you're asking makes sense.
let us work together to find what is most productive for you, right? Most helpful for you, right? So just think about it and we discuss. Okay, fine. So this is done. So now what's going on here? So is everyone confident? You want to just finish up the rest of the lab on your own, or what? Just one more here. This is too easy. So I leave this one open. You'll do it.
Yes.
Yeah, should be too easy. Okay, what about the other one now? The database, the pandas on the database. Shall we talk about that quickly?
Yes.
So, any comments first to start off?
So this is the same thing that we first did with database, and now we'll be doing it with Panda, right?
Exactly. I thought that if I use the exact same data set,
yes,
then okay.
It strongly brings out what is much more possible with Python versus trying to do it with DB or
Correct.
SQL.
Well, yes, I didn't even make it strong, because if I try to make it strong, it might be too hard for you. So I showed some basic capabilities, right? At least equivalence I have established, right? So what is going on here? Oh, that was the DB code. Where did I open it? So I don't know what I'm doing. Okay, here. Okay, so let's spend a minute here, because I think this is important. So how does the database show up here? Let me ask this question. Did anybody ask any of you ask this question? So here I said lab instructions, you will find something creates the database and populates it, etc. But how does the database show up here? Does anybody figure it out?
Like it's on the cloud?
No, but how did the data get in how did the database get created, and how did the data get there? And how each person got access to it?
Okay.
Okay, so now I'm going to say something which all database people should be like, I guess, I don't know. There's one file here that does all this for you.
Yeah, that part we totally saw because that's how I wanted, like, what is the value in each and all that. So that part. But when you say about ID password, you're using single ID password, right? Across.
No, there's no ID password. You get one copy of database created on the fly for you. How about that?
It's in memory.
It's in memory. Well,
Okay.
actually, it's the way it's done is it's because I didn't use in-memory database. It's actually writing to a file and then loading it into memory.
Okay.
But when your session starts, so it's kind of cool. When your session starts, the database gets created for you. See this when as soon as so it's really kind of very powerful what I've done. Do you see any code here to create the database? No, you only see an import, yeah? But I made sure that when you do the import, the database is initialized and given to you. Okay, so if you take out this import, you won't have a database.
Right. Yeah.
Okay, so it's all set up hopefully you like the way it's set up in a clean way. Okay. Now, the next important function, and I think Sachin asked me about this, but I think Kiran should read this as well because the answers to all our questions are here. And I tried to point you gently there, but so now
Rows and columns.
So, Kiran, do you see the answers to your questions here? Can you hear me?
Kiran, it seems to be frozen.
Okay. Yeah, I think she's gone even now, right? Yeah, she's disconnected. Okay, so let's just proceed while she connects back or something. So does everyone see this? Do you guys see this? Do you see how do I get the columns?
Mm-hmm.
How do
Rows
okay.
is, yeah.
Huh.
It's the first of description. It's the first column of the description.
So description is a tuple, the first cell. So
First cell.
does everybody know the distinction between tuple and list quickly?
Tuple is like a structure. It will have different things, but it will always be same length and yeah.
So the first element of the cursor dot description is actually the column names, but it's a tuple. But in pandas, you can set up a column by getting a list of values. So actually, what is done here is quite powerful, right? It's taken a tuple. It's taken a list of tuples. It's extracted the first value and made a new list for you. Right? And I want all of you to start thinking like this, right? Because normally that would be a for loop or a function or some extra code. It's done in line like this.
This is like a lambda thing, right?
No,
the way we write link queue.
So this is a relative to the, so let's just write some code quickly. This is a relative of the lambda, right? In the sense that, so this is also a functional programming technique. So what do we do here? There are two things you can do. You can either do a for loop. So let's make something list. Okay, so let's do this. Do you guys want to see this quickly or not?
Yes. No, I do want to see it because when you show me in the layman till take me to Panda, it's very interesting like how it changes.
Yes. Okay, so this one is very easy. So let's do a list. Let's make a list. Oh, sorry. Okay. Sorry. Let's make a list of 10 elements or something. So let's just look at it quickly. Oh, so of course. Okay, so I got a list of 10 elements, right? So now let's say I want to apply a function. So let's do it quickly, one quick review for us. For those who are comfortable with for loops, I want to apply a function to every element in this list, for example, right? So what would I do? I would do for I in nums, whatever. Let's do n in nums. Then we'll put a colon And then we will do, okay, so let's, whatever the function might be. So for the heck of it, let's do this as well. Let's def a function. Okay, so we got a function. For I in nums, you can do sqrn, right? This will create the square of the number. But I want to make a list. So now I have to basically create a list. So I'll say result equals empty list. And now I have to do result.append or something.
RES only.
Huh?
No, you have RES.
Result.append, right? And then let's see if this all worked. Then when we say rest, we should see something. Yeah, we got the squares. Right?
Correct.
This is our for loop solution. You guys are experts on this, so we don't have to say more.
Yeah.
Right, Sachin, you write this in your sleep.
Right, right.
So now, so now we'll see can we do better. Okay. So first step to do better is you can just do this. You can do map, right? QR F. Oops, not F. What is it called? Nums.
Nums.
I have to just check. Okay, okay. So this actually works, but it creates what's called a lazy list, right? It's lazy evaluation. It doesn't evaluate it. It evaluates it when you want it. Like for example, if you take the first value from here, it give you. Oops. I think you have to say dot next or something. I have to remember this now. Okay, I never use this anyway, so I'm not iterating through this map. So all I do is I just create a list. That's it. So which one's better now?
No, but I think this is when you're mapping, but you said now inside only you can do the lambda, right? I don't even have to def the square separately.
So, okay, so let's do that. So let's make cube now instead of square. Because I wrote square somewhere else. So I'll do lam that lambda x colon x star star 3.
Awesome.
Right? So whatever you want, you can actually do this. So now let me just take this and show you that. So let's just make it closer to our problem. Okay, let's say num equals, and let's make it a list of tuples. So just solve exactly the same problem we did. I don't think I need more than 2 elements, okay, just to do this. So now the idea is I want to extract the first element from each of the tuples.
Correct.
Right? So what do I have to do? I take this code, exactly this code here. And then what I do is I get x, and all I have to do is take the first element. So I'll just remove this and put bracket 0. Should it work?
It should.
Yeah.
How's this code?
Super.
Right?
But that didn't even have lambda and map.
Who didn't have lambda and map? The other one.
The one you showed there.
Yeah. Okay, so there's an equivalent technique, and each person has to decide if they like which one they like, right? There's an equivalent technique when you're manipulating a list to produce a list. So let's go back and do the square example. So you do this, you put I want to produce a list, so you put a square for a list, and then you say for n in nums. So it looks very much like your for loop. And then here you do the function sqr n, right? Oops. Oh, nums is a tuple right now. Sorry. So which one is nice? Is map nice or this nice?
This looks even nicer.
Yes, and this
because
works.
I know because of for word for it.
Because of what?
Because of the word for.
Word for it make you feel good. Yes. Okay.
But I feel like, yeah, the like map is more generic. I don't know.
No,
Can
no. Yeah.
be used
At
everywhere?
this level, they're equivalent.
Equal. Okay.
They're equivalent, right? I mean,
Mhm.
there's constructions which are equivalent here.
No way. You can keep adding, like in one line, you'll write the entire program.
So here, it's a nice functional programming example. Square the even numbers, right? So this is a filter. So if you do it with maps, you have to use a filter function to do this. Okay. If you don't, you can just write it like this inline. So yeah, there are some beautiful things you can do here, right? So this is what was done here. So let's go back to code board and look at this. You see here, that's all was done. I iterated through the description, extracted the first value. I didn't even need a lambda for that because I could just do x0, right?
Correct.
Yeah. See, so now you see there's a little bit of difference between how you do it with map and how you do it with, like if I wanted to, let's take nums list and do this again. If we wanted to take, where's this code now? Here, this one. If I want to take this one and do the extract first value, here I can just say, right? I can just say for n in nums. And then here I could just say n is now going to be a tuple. So I can just index the tuple. Oops.
Comma.
Y comma. Yeah, no commas. But I cannot map here by just say x0 here. It's not a function, yes?
Correct. Map
That's why
needs a function as the
that's
first.
lambda makes it into a function.
Okay.
So in this case, this looks even sweeter because I don't even need the lambda. I just do this, right?
Correct.
So you're gonna play with this. I don't have a formula that you should always use map or you should always use things. The guideline though is we should start thinking like this. By the way, you can also nest it, okay? If I want a nested list and all, you can do this. But for now, maybe we'll start with one list.
This is enough for today.
No, I'll give you a good homework
I'm
problem.
going-
I'll give you a quick homework. Huh? I'll give you a quick.
Uh-huh.
I'll give you a quick homework problem. I have two lists.
Uh-huh.
The classic problem to see if you can understand this. I have two lists. Let's say one list has numbers 1 to 10. Another list has numbers 10 to 20. Or whatever. Some two lists. I want to do what is called the Cartesian product. So Cartesian product means that for each element in the first list, I need. So you want to make a Cartesian product which is a tuple, right? You want to return me a list of tuples which contain. So if the first list is of length 5 and the second list of length 10, then the space of the Cartesian product is 5 times 10. It's 50.
50.
So you should make me a list of length 50, which has one element from here and one element from here.
there and the product.
And one line.
Okay.
You can do, well, actually, I can do anything. Later, I'll show you a function that does this for you also. But okay, now you try to do it with list comprehension or whatever. Like this is called a list comprehension. Okay. Try to make the set of tuples. Since I said this example of Cartesian product, and you guys like mathematics a little, and we touched on probability. Next time I can introduce this. There is obviously a simple data structure called a set.
Correct.
That is very powerful, but like all sets, it has certain nice properties which we can use. Union, intersection, all that stuff can be done. So you can do the basics. Since I said Cartesian product, you can take sets and do the Cartesian product on sets using comprehension. Okay. So much for this. I will pause here. Okay. Now, what are we doing next? Okay. So I put something here. So anything else on this particular exercise? Oh, sorry. I just to wind up that part. What was the first section? Anything here? Question?
Create a function that will compute and return min and max values for date of birth of student. Okay. No. This is like very easy in the pandas, right? Because it is like dot min, dot max, and yeah.
You guys are already quasi pandas experts right now. You should feel comfortable.
And like doing it in the lab 2 versus lab 3, I knew it. I didn't come to lab 3 because I felt I'm still not up to mark in lab 1 and 2. So
That's fine, right? So now you'll play. You try, okay, and try to find words when you get stuck in something. Just try to find words, okay.
mhm.
Try to find words for what's blocking you. Don't sit there and say I'm not smart, I'm not clever, why I'm getting stuck. Okay, don't. It's not. That's not the important thing. What I want you to just say is, Vijay, I tried to do this and then it didn't work or whatever, and then we'll fix it. Welcome back, Kiran.
You're on mute.
Yeah. Kiran, I think you are not destined to understand how to get the column names from the we won't even discuss it because every time I try. Kiran's been asking me for 2 weeks. I sent her some emails. I explained.
So I will check with Pallavi this time.
Pallavi's laughing. She's like, "That's
Yes, No. I'll definitely. That's my way of getting my practice, Kiran. I'll tell you.
Okay.
okay." So, so I think the mood in the room right now is, at least Pallavi and Sachin are saying, the lab is too easy right now. Just give me some quiet. Give me some quiet time. Huh?
Never said that.
I was
The
trying to.
question that you have not asked in the lab, which is actually in Jupyter, is harder. Like, find the age and all. Like, once we find the probability and I don't know. Like, I think you want us to come to standard deviation.
Yes.
I've forgotten the things to know. Like, if something is missing based on the like the sex and survival and everything,
Yes.
what the age should be.
Lab 3 in particular, I see that the questions given are much easier than what is there in the Jupyter notebook.
Not
Lab.
much. Okay. Yes, maybe because I want.
Yes, Vijay. The Jupyter notebook has so many tough questions, and we have to actually solve those first.
Yes. No, I didn't want to make the lab because you guys are having little trouble with the lab. I didn't want to make it too hard. Right. I was hoping we'll just discuss it in class and then I can show you the solutions. Okay.
Vijay, I completely agree with you on this thing that lab should not be that hard.
Yeah.
Those who want to practice hard things can go through Jupyter notebook, but
yeah. Exactly.
grades should come based on easier questions.
Yes. So now I have an interesting thing. We could spend some time on this notebook, or we could. I can quickly show you a couple of visualizations. Which way do you want to go?
Visualization.
Okay, yeah. So can you guys do, okay, I have to get, I guess I'm going to get a link. Let me see if I can do this. Give me 1 second. I need to get a, can I put something in chat? Can you guys pick it up? Okay, let me see. Can you get everyone has this link now? So if you go to this link, make sure you hit clone first. Right, when you come, are you able to click and come to this page?
Okay.
And make sure you log in, okay? On top right, instead of seeing you log in, if you see sign in, you should sign in there.
PJ?
Yes, tell me.
I have a problem. I have a default Office login to this thing. I was thinking if I could log in using some other
Incognito mode. I also have a default login Office. I used incognito mode to go to Jupyter whenever I want to.
How do I do that, Pallavi?
Chrome, you just do incognito, or like if you're on this thing in private browsing.
Which browser are you using, Kiran?
So I'm using Chrome.
Okay, can you see this? Can you see this drop down now on my screen? Or you can't see drop down? Can anyone see a drop down on my screen or no?
Yes, yeah, I can see. Yeah.
So if you hit in the top right hand corner, there's like 3 dots. If you click on it,
Yes.
it will give you this drop down, and there's this one here, incognito window. The Control Shift N. What about the others? You are able to get here or no?
Yes, I am.
Yeah, on the notebook. Yeah.
Yeah. So just execute the first cell. It will take a second. Okay, just run it. Okay. So let me explain now. There is so we're going to talk about visualization, and the bottom line here is it's extremely powerful tool for us to see things, especially in data, especially when we're looking for patterns, right? The only problem is that we seem to need a slightly different language to create these visualizations. And I don't think we have fully found what does it mean, okay? But anyway, that's the background. The main library here is called matplotlib, okay? And what has happened is extremely cool here. Matplotlib is a library that will actually take information and create visualizations for us. There is an add-on library here, which is called Seaborn. Seaborn sets up some default styles and colors and so on. And it's also got some functions built into it. So today we won't spend too much time on Seaborn. We'll talk a little bit about Matplotlib. We'll see how far we get. The next thing is every time we make an image. So remember, this is like a very cool idea that the plotting library actually creates graphics. And right now, the graphics are static graphics. Later, I can even show you how to make it interactive. So that means I can have a slider here and you change the slider and the graph will change, right? So we can make not only graphics, but also interactive graphics, okay? So the next thing is, okay, so a lot of words were said. So now let's just make something and then we'll come back and talk about more. So yeah, I guess the last thing is when the graphics comes up, there's an extra piece of work here, which is show the graphics not in a pop-up window, but inside Jupyter itself. So in order to make it show inside Jupyter, I have to put this line here, %matplotlib inline. Okay, and then the image will show up inside Jupyter. These images can also alternatively be shown in an external viewer or can be saved as PNG files or JPEGs or whatever if you want to send it somewhere. Okay, but for now, this is very cool that we can have it right in place. Right, when I make an image, I don't have to go look anywhere. Just to say, 5 years ago, you couldn't get it inside something like this. You have to have a separate file browser and open it and all that stuff. Now it's all very clean. So let's just get started. So let's understand this code. So I just want to do something here. I want to visualize what does the function x squared look like. Okay. So what do I need to do to visualize it? I need to take a bunch of x values and square it and plot it, right? So how do I plot it? I plot it here by saying, first, let me create the data. So the data is being done by this right now by this library called NumPy. NumPy also like pandas. So we can do this equivalently in pandas. We'll come to pandas later. NumPy is heavily used for mathematical manipulations, but it has the same idea. It has arrays. NumPy arrays are like pandas series and data frames. In fact, pandas under the covers just delegates to NumPy and works well. It uses all of NumPy's storage mechanisms, and you can initialize pandas with NumPy arrays and so on back and forth. Very easy. Okay, so what do we do here? NumPy has, just like Python has range, NumPy has a range. So I just use NumPy's a range function. And what is nice is that if you do NumPy.arange, you can square all the numbers like this. How about this? So let's take a moment. Does everybody understand what happened here?
Yeah, like no mapping also required. Every time it is like shorthand.
Yes, it is like shorthand. So then you have to learn the shorthand a little bit. Okay. So what is happening here is because NumPy arrays, you can apply a function to all elements of the arrays by the syntax as you will apply it to a single value. Like if I had a number 10, so I want to square it, I'll do 10 squared like this, or if I want to multiply by 2, I multiply like this. A NumPy array can be multiplied, all the elements can be multiplied by doing this. Does that make sense? Let me pause for a second. Quickly ask me if you have a question here.
So this is not what we can do in Panda.
We'll
Can we do
back.
it on data series also?
We'll come back. Yeah, you're gonna create a series and you're gonna try. Okay. Okay. But stay with me here. Okay. So now I've got X values, and I got the values here, and I can just plot them, right? So if I say plot, notice I've given only the. By the way, I don't know. There's a bug here. Sometimes I have to run this thing twice for the size to kick in. Okay. I don't know why. If any of you figure it out, let me know. Okay. So here I'm setting the size of the image because it's a little small by default. But sometimes I have to run this query twice. Otherwise, it doesn't set the size correctly. Okay, so we got this. Does everybody understand now? Some magic happened. Matplotlib actually created a default index here, right? Without specifying X values, it automatically used a default index, which is the index of the list. Does it make sense to all of you?
Yes.
Yes. So for example, if I had done something slightly different, if I took all the numbers from 10 to 100 in steps of 10, and you look at this plot, you see the difference, right? It's still going from 0 to 8 or whatever, 0 to 9. It's cut off a little. Yeah, I have to check why the last digit is not showing up. Okay, but it's still. But these are not exactly the X values. These are the index of my array, right? The X values are what? What are the X values for my data?
Y values, right?
No, I know. These are the Y values. What are the X values? So, okay.
Got it. The X values are actually 10, 20, 30 till 90.
Correct. Right? So let's do this in a slightly different way now to make the X values explicit. Okay. So the first point is, if you don't have X values, it's actually trying to help you and it will actually create it for you. But if you have X values, you can do this, right? And then we're going to plot this, but it's not using the X values yet. But now I can say X comma Y. Now we got the right plot. Makes sense, right? So first
and
step.
it has 90 now.
Huh?
Oh, that's because it's starting with 10. Okay.
Yeah, starting
now
with
I
10.
could see 90 also there. So.
Yes, maybe it did it nicer now, right? I don't know why exactly. I have to go check what happened there.
That time it was starting with 0.
Yeah.
Now it is starting with 10. It is only showing 9 at the end.
But I don't think it has anything to do with 9. Like, for example, we could have easily done this, right? Oh, yeah. So it's basically my graph is getting cut off. That's what's happening. I think so. Let's see. 12 by 8. What is length? Let's just make it. Yeah, it's still getting cut off. So I have to go check what is happening here. Okay, I'm not sure.
Okay.
Never noticed it before. Okay, so fine. So now I'm going to give you all a very interesting question before we go to the next one. How many of you are good in trigonometry?
Again, maths.
I can do it. Okay. So, what is the difference between sine and cos? I don't want to huh?
Sine is like opposite upon this versus.
Yes, that's the definition. But now think of sine as a function of angle, right? Sine x is a function, right? I change x from what values can x take when I change sine x?
0 to 90.
Then after 90, what happens?
Mm, okay. It takes minus values, right? So, so sine curve starts from 0, passes through 0, goes down, comes back to 0.
So,
So
so yeah, when it comes back to 0, what is the value of x?
180, I think.
360. Well, first time it comes back to 0 is 180, then it comes back.
180 second time.
Yeah.
Okay.
So the function repeats every 360, right?
0 to
Okay.
360.
So think of sine as a function of x.
Mm.
Think of cos as a function of x.
Mm.
There's also the definition, opposite by hypotenuse, adjacent by hypotenuse. Don't worry about this now. Think of it. And x is the angle of that triangle, right? So as you change the angle of the triangle, we're seeing what happens. Okay, fine. So now I'm asking you, as two functions, what's the difference between them?
So cos, I think it's above 0. Or, it is like off by 90 degrees. I like.
Okay.
Then.
Okay.
Yeah,
So you're getting close to what I want. That's what I want. Okay. So now I'm going to
it's
tell you.
actually 90 minus sine. Huh?
So you're going to say a lot of things. Now I'm going to show you one picture and we're going to be done with this. Right? And we have to ask the question why we didn't do this picture in high school. Okay. So let's make this picture first. So what we have to do is basically, I'm saying, let's not have all big discussion. Why don't we just make the computer draw the two functions, put them side by side, we look at it. And then we ask the question, what's the difference? Yes? Agree? Okay. So let's do this. So very interesting. To make a function, I have to choose x values. Then I have to tell the computer calculate the y values. So the x values are chosen here, just linear points. But there is also, in mathematics, we use this function. It's also like a range. I could have done it the other way. I'll just show you one more function. It's called linear space. And linear space generates points between 0 and 10, but I can generate 100 points. Make sense?
No, I didn't get it.
Okay, lin space is exact. Suppose I put here a range. Can you just tell me what?
So it's starting with 0. But how can it go in steps of 100?
Cannot, right? So you have to use here decimal steps. Okay, I want, let's say I want 100 points from 0 to 10. What should be the step size?
0.1.
Between 0, I want to take this interval 0 to 10 and make 100 steps in it. So how much should be each step size?
0.1.
Yeah, so you have to use a decimal, right? 1 by 10.
Correct.
Right? But suppose I don't want to do all these decimals. There's an equivalent function. It's called linspace. Linspace, you specify the interval and you say how many points you want. It will take care of everything.
Okay, got it.
Is it a nice function or you want to go back to a range and use decimals?
No, this is better. Like not worry about step. I just want to set the total number I need in between.
Yeah, that's it. Right? So yeah, so it's a nice function. First time I found this function, I was like, cool. Because remember, this is all cutting out for loops, right? Suppose I said, I take an interval and give me 100 points in it. What will you do? For loop, something, start here, stop there, something, right? It's going to be work. So I hope you see that compactness is very important to use these right tools, okay? So anyway, so now I want to make a figure. So Matplotlib has this thing called figure, okay? Later we can discuss all aspects of it. Right now I want a figure. I just initialize the figure and then I say plot, and it's the same as before. Same function as before, plot. I give the x values and notice the power of numpy. I have to apply sin x to all of them. All of the x values in a vector. I just pass the vector to numpy and he take care of it. No for loop, no map, nothing, right? But we have to understand what we're doing. X is a vector, x is a vector, x vector means a list of points. So the first line calculates sin x. And then in the graph, I want to distinguish them visually. I want to see who is sin x, who is cos x. So I can say use dashes for x, sin x. And I'm going to use dots for cos x. Make sense? So now we run this function. We got something.
How did the colors come? Is it like
auto assign? You can control it, but it's auto assign. Okay. Like for example, I think I can say, so let me see here. So this string here is actually a style string, okay? So let's see what happens. Can you see the difference in colors now?
Hmm.
Or no?
Yeah, it is red, right?
Red. So R for red and O for the symbol.
Ah, okay.
So if I don't want R, I can say blue or some green or something. I don't know.
Nice.
Okay, so this string is
Lot
quite
of
powerful.
shorthand.
Huh?
Lot of shorthand. Lot of shorthand.
Yes, we're starting a world of lot of shorthand. But okay, but for the shorthand, now let's look at the picture. You notice that if you take cos x or sin, if you take sin x, either way you can do. Take cos x and move it forward. Just slide the green curve to the right. It sits exactly on top of the blue curve, right?
Mm.
So this is what our teachers tried to teach us by saying sine and cos are kind of shifted from each other, and there's a notion of phase shift and all this stuff, and it's very hard to see, right? You try and you try, but you never see it. But now I'm asking, it should be immediately clear for you to see this, right? And homework exercise, try to shift cos x by 90 degrees. Shift all the values by 90 degrees, you'll get the same curve.
90 degrees.
Yeah, if you add 90, I mean, you have to add correctly, okay? But if you add 90 degrees, if you add 90 degrees to every value of x in cos x, right? You should
Oh,
get,
yeah. Yeah.
I'm tempted to do it for you right now, but maybe you should do it as homework.
Yes.
So your job is to move the green curve to the right by a certain amount, and it should sit exactly on top of the blue curve.
Okay.
Okay. Quick question for you. If I taught high school mathematics like this, would it be more understandable or not?
It would be awesome. It would be awesome.
Because I think that this kind of ability to make some code and see what's happening and explore it, I never had, right? We barely had calculators, not even graphical calculators. And teachers get angry if we touch a calculator. So we were not encouraged to explore like this. But I think there's a lot of cool exploratory mathematics that we can do. Quickly write something, try it and see. Okay, but anyway, back to data science and data management. These tools are coming back. We're going to use this to explore data. Okay, so the first thing we saw is just a simple plot. Okay, so now I'm going to teach you another. Quickly as I do visualization, I'm going to show you, I can show you some really powerful ideas quickly with a picture. So just now I taught you the difference between two trigonometric functions with a picture. By the way, you should, once you're here, you should as well try tan and everything, right? I mean, notice how quick and easy it is. You want to see what tan looks like? It's going to mess up my graph a little bit. Anyone want to guess what tan looks like? Let's see how much trigonometry you guys studied.
Sine by cos is sine by cos.
By cos x, yeah.
Yeah. So I know the definition, but what does the graph look like?
So first will be 0 when it is.
So the surprising thing is, sine and cos are nice looking functions. But tan will mess up the whole graph. Okay, let me see. Let me take the other guys out.
Seriously? No, I don't understand this.
Okay, since you don't understand, let me explain quickly. Tan is a very bad function, right? Because it's sine divided by cos, but sine or whatever. Yeah, sine divided by cos, but cos vanishes in certain places.
Because of divide by 0.
And now you see the divide by 0, right? So these actually, if you put more points in there, it runs off to infinity. So we don't even notice, right? Sine and cos are like nice wavy functions, and we think, oh, tan must be like this, but it's not at all like this.
It goes from 0 to infinity, then minus infinity to 0, 0 to infinity, minus infinity.
So it's not periodicity, it's a repeating function, but it's very, very different. Right? Yeah, that's why I said, like in 2 minutes, we can learn all this. If you try to do all this by hand and so on, or you see it in a textbook, you don't know how they made the image, so you don't fully understand it. There are graphs in books, but if you create it yourself, you can learn it much better. So yeah, feel free to explore. Think of other functions, okay? A homework assignment, you can play with this. Think of things like logarithm, for example, and we can talk about it next time if you want. You know, like strange, simple mathematical functions we're supposed to know everything about. If you don't visualize them, we don't really understand them. So now I'm going to show you another domain. How many of you have heard of a random walk?
Random walk.
Have you heard this name?
No, I have
Okay.
not heard.
So it's a very powerful idea. The idea is related to statistics and probability. Okay, but the idea is the following. Suppose I start at some origin. Okay, the one-dimensional guy starts at some origin, and you can do it in two ways. You can flip a coin. If it comes heads, I will move to the right. If it comes tails, I'll move to the left. Right? And that's all I keep doing. And the question is, after some time, after some 100 flips, where will I be sitting? And what is my path? Make sense? So he won't move like a normal particle, right? He won't go like smoothly like this. He'll go back and forth like this.
Correct.
And it's a branch in mathematics where people study this kind of things, right? Because there are many things in nature that behave like this, right? Which are randomly determined. And we want to ask curious questions like, if I wait for, say, 1,000 steps or 10,000 steps, will he be very far away from the origin or will he be close to the origin? Right?
With 50% probability.
No, we have to calculate all these probabilities.
Ideally, he should be wherever he was. Origin. He keeps going right, coming back left.
No. So yeah, but he can go 2 times to the right if he gets 2 heads. Okay, and if he goes away, will he come back? How often does he come back to the origin? Right, very, very curious, beautiful subject. Okay, now you can do this slightly differently. You can get a random number generator, generates numbers between minus infinity and plus infinity, a Gaussian. So Gauss normal distribution. You've seen this hat function. We can talk about it later. But so I pick a number between minus infinity and plus infinity. The mean of it, I'm most likely to get a number 0. Then between 1 standard deviation, I can get 60% of my observations between plus 1 standard deviation minus 1 standard deviation. So I pick these random numbers and I jump by that much amount. Right? So I could jump by minus infinity, but it's very 0 probability that I will get minus infinity jump. Okay? And now the question is, again, same thing. After some time, where will I be? So we can ask all these questions. Okay? But now I'm saying, let's go make an image that shows how does it look. What do you think? How many lines of code to do this? Should be a couple of lines of code. Okay, 1 line of code.
Yeah.
Yeah.
That was what was expected. I don't know how it is 1 line of code, but I was sure it was 1 line.
Okay, so let's see. So, but 1 line of code to make all the data and 1 line of code to plot it. Okay. So how do I make it? I pick how many steps I want to make, 1,000 steps. Okay, I go to the random number generator and say, give me that many random steps. Then each time I have to say, okay, so let's say I took a step of plus 10 and then I took a step of minus 10. So my new position, if I go to plus 10, my new position should be 0. Right? So basically my position at time t is the sum of all values before that time. Do you agree or not agree?
Yes.
Right? Everyone sees this, Sachin?
Yes.
Yeah. So basically I have a list. So here's the thing. Okay. I have a list. General problem. I have a list, but for some reason, you pick any sub element of the list, some location M, all the previous values before M should be summed up. You have to create a new list with all these partial sums. Make sense?
Like cumulative.
Cumulative sum. Okay, how many lines of code? It's a lot of lines of code usually, but actually there's a nice little function. It's called cumulative sum.
And this is in Panda. Okay.
This is in NumPy.
Oh, this is in
Also in
NumPy.
Panda. It's also in Pandas.
Okay.
Okay, so cum sum, right? So I do cum sum, and then I create a Panda series out of it. And the series has an index. The index is the
range.
step
1000 steps.
number. So I got a panda series, and pandas knows how to plot. So you don't have to do any matplotlib. Just say pandas, you got a series, just plot it for me. Okay, and then pandas plots it, and we got this. So now I'd ask this question: have you seen anything like this before? Okay, you should just on the side, you should just Google for 1 year's worth of Yahoo stock price or something, or Google stock price, sorry.
Oh, okay. This is like, yes, stock prices.
So that's one example. There are many interesting phenomena that look like this. Okay, but I just wanted to say, look how easy it is to take something quite complicated, then translate
And
it.
every time it will be different, right?
What is it?
Every time you run, it will look different because it's
Well,
random.
right now the way it's done is the random numbers have a seed, and the seed is fixed right now. If you change the seed, yes, every time you run it will be different. Right now the seed is fixed. So you have to say random number dot set and change the seed. If you change the seed, it will get differences. But also notice I can make this, look at how powerful this is. I want 10,000 points. Last time I did 1,000 points. I want 10,000 points. Done. Right? So you can see all this kind of things. Notice something very interesting. It starts at 0. So actually when you see 1,000, you'll see the question we were asking before. What are the chances? He started at 0. He came back to 0. You see in the vertical axis, he's coming back to 0. He's going away from 0. He's coming back to 0. He's going away from 0. He's coming back to 0. Right? He's going very far away from 0. He's coming back to 0. So it keeps coming back. So this is also very interesting. This is what happens to gamblers. Right? The guy thinks I'm doing really well. I'm making money. I'm making money. I'm making money. Boom. Suddenly he loses everything, comes back to 0.
Truly random. That is what will happen.
That's what happens, right? But what is surprising to us is that we didn't think that we would go so far and then come back. Right? We thought we'll always be close to the origin. Why we're going so far? But actually, it's likely
More
that
like a sinusoidal curve.
Yeah.
It just keep. Yeah.
Well, it's so there's a whole branch of mathematics studying all these things, right? How many times, if I tell you a number t, how many times does it return to the origin? Blah blah blah. All these kind of questions. Okay, and very cool stuff. Very different mathematics and physics than what we normally study. Okay, so just to show you that you can also create a data frame with 2 graphs, 2 random walks, or 100 random walks, whatever you want. And if you say plot, it will plot. So the bottom line is 2 things we learned. If you have a series, we can just call plot on it. If you have a data frame also, you can call plot on it. With a data frame, you have the extra thing of specifying which columns you want to use. If you want to use all columns, you don't have to specify. You just say plot. If you want a subset of columns, it's like in this case, there are 4 columns, right? So I can say A, B, and D, for example. And then I get 3. Right? So if you have pandas data, you can just say plot and it will just go plot it for you.
The 3 are different, right? How
3 are
come?
different.
Because
now,
there are 3 different 1,000 random numbers.
Correct. So the first 1,000, then the second 1,000, and then the third 1,000. Right. So
that
even though it's
became 4 columns, is it?
Huh?
Like the 4 up to 4,000 random numbers. First 1,000 became 1 column. Second 1,000 became second column. That is what it is here.
Yes. Yes. So how did that happen? How did I make 4 columns? Okay, I'll show you here. But
Comma 4.
okay, you guys want to figure it out? Yeah, comma 4. Innocent looking comma 4 here. But the comma 4 says, create me this many random numbers and give it to me in 4 columns.
Okay, so it is actually 254 times, is it?
Correct.
No, it is how. Is it totally 4,000 numbers or 1,000 numbers?
Yeah, we can just do this here. Let's do it like this. Uh, 1,000, 4.
4,000 numbers.
Yeah. right? So anyway, again, the moral of the story here is you see how the story is, right? First you have to get the right question, and then you have to use the right function, right? If instead of doing comma 4, if I got 4,000 numbers and I split it myself and all that, I will be writing a lot of useless code, right? So you have to use the right thing. Okay, so much. Any questions on line plots? Everybody comfortable? If I give you pandas data, you will be able to plot it.
Dot plot.
So now the next one, it's called a box plot, right? So instead of drawing a line, so the line is used to study the relationship between X and Y. But a box plot says if each column has some number of elements in it, and I want to know I want to know how much is in each of those things, then I can do a box plot like this. But it's called a bar plot here. So you can take a series and say series.bar. Okay, and I can control the color, and alpha controls the transparency. So this is beginning to show you how much control we have, right? If I want to make it very transparent, you do this way. So it becomes very. So this is what makes this whole story very complicated, right? All these extra controls means there's lots of parameters. And so you have to know how to use all of these parameters well. Okay, so same thing. Now, sorry, any questions on Boxplot?
So these things, are they like similar across different libraries of Python that, like it will be once you learn in one library, it's
More or less.
reusable?
I will say more or less, but it's not exactly standardized. So I would recommend learning Matplotlib because it's the oldest one, and later I can show you other libraries. The new ones, they change these patterns because they say we make it easier for you. Then you have to decide whether it's really easier or not. But I think you can just learn, huh? Sorry.
What really is a box plot?
Sorry,
like,
Kiran.
Yeah, I said what really is a box plot?
Oh, you became faint suddenly. Can you say that again one more time?
I was asking what is a box plot?
So a box plot is basically for each. See this, there's an index, right? So the index goes A, B, C, D, E, F, G, H, I, J. For each element in this index, show me the value, but show it by the size of the value. Like for example, the value here is 0.5 or whatever, 0.4 something. The value here is minus 0.4 something. So let's see, let me show you Escape. So you say S1 like this. You see, these are just the numbers here, right? So imagine, where would I use this? That may be a better way to ask the question. Imagine I had a data set where the index was the names of countries and the values was the population. Right? They will all be positive, but it'll be nice to see them as heights, right? So does that make sense now?
It does make sense, but is it only so in that case, this box plot, when it is countries and population, this box plot will convert into a plain bar graph. It will no longer be like this, which looks like.
I say box. Yeah, some people call it boxes, some people call it bars. So
Okay.
yeah, you can call it bar if it makes it easy. Actually, the API says bar, so maybe I should say bar plot here.
Okay.
Yeah, I don't know if they call it maybe bar, whatever, bar chart, bar plot. Yeah. Right. Yeah. So yeah, it's just, so what is it? It shows you how big those values are. That's a quick way to see, right? Okay, but now that doesn't look so interesting, but now let's make a data frame. This might be more interesting. So I have 4 companies or whatever, 6 companies, and each one of them has some amount of, some metric of the company. Profit and loss, employee count, whatever, some metrics, right? And I want to visualize how the 4 companies are, right? Again, same thing. I create the data frame for you. If you have actual data, you can put it in and make something nice. And I just say plot. And you see what a beautiful graph I got. It's by each company. Each of the metrics is given the appropriate height. Different colors are created for it. And there's a legend here that tells me what it means. My chart is a little boring. It says A, B, C, D, but it would have said profit, employee count, revenue, blah, 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 right? Can you guys take this and make some nice plot with some real data? Just have to create the data. That's it. Yeah.
Right.
Is it nice?
Yeah, Vijay, can you also open this?
Oh, sorry. One more time. You have to hold that thing close to you, I think.
Yeah, okay. I said, can you open the lab for us?
Open the lab. What
Yeah.
is it?
So the visualization chapter 4 or lesson 4 is actually not.
Yeah. No, I just gave you a link directly to this page. I didn't put a lab there yet. Because I don't know how to, actually, honestly, I don't know how to do this lab. I can make you submit the notebook itself. Because how will I can't auto grade the visuals.
Yeah, Vijay, we can do on the notebook also.
Yeah. So just do in the notebook. So here's what you do. You do in the notebook, you've cloned it, right? You've cloned my notebook. You do whatever work you want. And then there's an option to share here.
Okay.
So just copy link and email me or copy link or whatever, right? Or I can create a submission form where you copy the link and put it on the website. I don't know. For now, just email me, right?
Yeah, Vijay, I think I wanted it only for practice. So if it is open, I can do that.
Say that again one more time.
I said I wanted it only for practice. So do I have to keep this link or can I just open chapter 4 and go through the Jupyter notebook?
No, right now, okay, I can put it on the website. I didn't put it on the website because I didn't know if we were going to cover this section. When Sachin said I want some visualization, I said, okay, I will just give it to you quickly. I can put it for completeness, I can put it on the website, but it might take me a day or so to do it.
Okay.
Right now, just keep this link with you, and then make a bookmark or something, then you'll have it.
All right.
So anyway, so where are we? So okay, so here's Boxplot. Now the same boxes, instead of seeing separately, you can also stack them. So instead of seeing 4 columns like this, you can see them like this. So if the 4 columns are adding up, right, to give you the same quantity, then you can stack them so that you can see the total and you can see the composition. Okay. So now anyway, so this is the moral of the story, but now I'll just give you an example quickly. Oh, Kiran wants the link. It's not in your chat, Kiran. Yeah, you have it?
Yeah, I got logged up.
Okay. Can you see it now? I chatted you.
Yes, I can see.
Yeah. Okay, so now let me show you this quickly now, just like we did with the past. So I got the Titanic dataset. I import Seaborn. I say load Titanic dataset. So let's see if the load is working. Now, Seaborn has a very nice function here. It's called count plot. So what did we want to do when we calculated the percentages? We wanted to count how many males survived, for example. So in Seaborn, there's a plot called count plot. And you can get different colors. So I've set the color based on whether you survived or died. And I passed in the X values, I passed in whether you're male or female. And then I passed in the whole data frame. And then run it. Now, can you guys look at this? Oops. Oh, so it's, what is it? That's strange.
Data is equal to Titanic.
Data is in Titanic, that's why. There you go. So what does this image tell us?
More male died.
Yeah, more males died.
Like the probability of men dying was higher than the female.
That's it. But isn't it nice that in one picture I could get this quickly?
Yes.
Whereas if you look at the data, there's no way you could see this, right? I mean, you have a lot of data. How are you going to figure out this pattern is in the data? Yes?
Yes. Yeah.
So who likes charts now?
I was not a previously very big fan, but now it's like always trying to use in Excel also, like, trying to visualize it and see, and So
Okay,
it
now
is
compare this to Excel and tell me this is like a million times better.
definitely.
Excel, you have to highlight all the ranges and you have to do all kinds of stuff. This is so much better.
Pivot table and this and try to I decide what kind of pivot I create and then use that to chart it out and yeah.
So that might be a good thing, Pallavi. You have to design this, okay? Design, here's a question for you. You can coordinate with Sachin because he's in charge of coming up with some interesting projects. For you, a good one would be, what are the things you want to visualize from a Scrum data?
Yes.
Okay, all
That
the
is
typical things. How will I create a burn down chart? How will I create this? How will I create that? So you should do that.
velocity across different sprints and
Yeah.
whether it is increasing, whether it is like,
Okay. Can you
decreasing.
make a design first design the data? What data will collect? But you
Uh-huh.
can put dummy data, okay? And
Yes.
then you can use visualization, and also you can use pandas to analyze that data, right?
Hmm.
So, but you have to take some time to think about your data, okay? You have to think what
Correct.
are the parameters, sprints, velocity, by developer, by sub team, whatever is relevant. You can make some nice data set, and then we can do some quick reports.
Yeah, man.
I don't-
Like, my manager will definitely appreciate it.
See, Pallavi gets appreciation, we're all happy. Okay, but no, I think it's interesting, right? I mean, the idea which I'm sharing with you is, if you have a right process, collect the right data, ask the right question, and then create the right analytics on top of it, right? We don't have to get very sophisticated and do some complicated data science. If we ask simple questions like this, right, then we will get very interesting information back, right? And then we'll make nice reports. And hopefully those reports will be interesting to either management and or the team. Ideally the team, but okay, as well the management. So I think I'll pause here. Talk to me quickly. How was visualization?
It's good, yeah. Good, Vijay.
Okay, I'm glad you like it.
No, Vijay will definitely want to try this Jupyter notebook
Yes.
out and let you know. Yeah.
Yes. So, but my point to you, hopefully I've got you to this point where you can see that this is all I was imagining, hopefully for me when I started the course, that I could get you to a point where you can see, you can do some things, you can see what the tools are capable of. The rest is now some practice and we have to do some work. And like I discussed with you, just saying I'll go home and practice by myself, the chances of success is low. If you're very disciplined, maybe you'll do it, right? So yeah, it's kind of easier. Even for me, it's easier. Like if you come to me and say, Vijay, how will I do this? Then I'm prompted to try to answer that question. To leave me open and say, come up with something interesting to do, it's very hard for me to figure out what to do. And I get lost. So don't let that happen to yourselves, but you must keep playing with this, and hopefully there's enough here for you to say, yes, if I learn all this stuff, I can use it in many ways, and it'll be fun as well. Forget about utility, right? Even learning should be fun. So with that said, what else? I think it's time to wind up. So
Yeah.
I want a small favor. Can I ask all of you, if I make a quick survey for you after the course is over, it should take no more than 10 minutes. I usually try to be disciplined and collect some information. And usually I try to use it to make things better or whatever. Maybe you can encourage me also. I mean, if something is good, then you can tell. Is that okay?
Yeah, sure, Vijay, sure.
Huh?
Definitely, Vijay.
Yeah,
Definitely.
definitely, sure.
So I will design that and mail it out to you. But okay, when we started this course, you didn't have any idea what we were going to do. I remember Kiran saying I should do a session and explain to you what we're doing and all that. Now we are here at the end of the course. So what did you imagine it was going to be like this or not like this or what?
But I think I can do much more what I am doing right now.
And for me, this has been a
But yeah, it will
revelation.
take some time. Yeah, practice required. Yeah, for sure.
Yeah.
No, I started out with something else, but
Yes.
the kind of power that Python brings, and I have been listening. Like I have, Kiran knows. Like I was part of the internal e-learning kind of this thing. So we knew the courses that were coming in, and Python was everywhere. Okay, but I had like something. It is something that new people are all doing. But to have some idea about it now, and to see the possibilities with it, okay, it is really amazing, and it has basically intrigued me enough to keep continuing in this
Yeah.
direction. And this was going to be a very personal thing that I want to learn for myself, but
Yes.
now I've declared it professionally that I'm learning this, and they want to use me for data science projects in future if I
Okay.
learn this. So
Okay.
so it,
Okay.
it is like a merger of personal and professional goals that I'll be making
Yeah,
it.
that's excellent. I would say to you, like there's a lot of upside here, right, for all of us, because that's a growing field, right? And so to have some familiarity, right, understand something, right, instead of saying I don't know what Python is, no, you can say at least I know what it is. I'm not an expert, but I know something, right? Somebody says, is Python good for visualization, or some conversation going on like this, you can have some opinion, right? And that will open doors. And of course, other things that are hidden in your background, if you like mathematics, if you like to learn something like this, that can help you to become an analyst, data analyst, or something like this, right? Even as a project manager, you can be more quantitative. Things will start falling in place, right? So first we have to develop the skill, and then we can exploit it, right? We can use it for lots of things. What about our style of working together? How has this been compared to normally when you're learning something?
It's really good, Vijay. Actually, I like that.
What aspect did you like?
The working like a aspect like the way actually you trained us, and you like given us the material and the exercise labs and Jupyter and everything. So it's a very good learning experience to work on that, and then we have a homework and to submit the labs and get the grades. So at least we can motivate ourselves actually.
Yes. So by the way, this is I'm sorry to put the burden on you guys, but for me, this is very, very important, because I think that very often people ask me like, why do you want to do this? There's so many courses there, other people are doing it. But every time I finish a course, I feel like we did something that is different and so on. But I cannot explain to anyone. I can only, like, once you're here working with me, then you see it, then you're like, okay, I know what it is. That's how Kiran also, like, she's working with me. She says, okay, Vijay, you teach me something, I will learn something, right? I mean, I have a chance to learn it, but I can't explain to anyone. So sometimes I ask this question because I can use your words. I can use your words to tell someone what happened. So
That we internally decided. It was like this, that we wanted to continue with the practical Python data management
yes,
from mid of July. Before that, we want to give some time to ourselves so that we can practice a little.
yes, I think that makes a lot of sense. In the meantime, when you practice, but make sure you do it, okay? Don't let it fall off. Just send me email or whatever, ask me questions. I'm happy to motivate you to keep working on it, right? And each other, right? When you chat or something after a week, ask each other, did you do something or whatever, you have got something interesting, whether it's code or it's a question, it doesn't matter. Like if Pallavi comes back and says, I figured out what data I've created for agile analysis, I need these fields and these columns, blah blah blah, that's also useful to us. If Kiran or Sachin comes up with some practical problems, they want to analyze something or model some data, then also we can use all that. Okay, so I will not hold you guys longer, but I will wind up for today, and then we'll be in touch. And it was really a pleasure.
Yeah.
I enjoyed working with all of you. It's really nice.
Thank you so much.
Yeah. Oh, Pallavi is here. Okay, just in time to say thank you.
No,
It's
I just got dropped off.
yeah. No, I'm saying that for me, honestly, I would if I had more people like you, I would just do this full time. I would just want to help people and teach them things and show them stuff. But it's a big challenge to find people like you who want to learn something, and then it's an even bigger challenge to explain why what we are doing is probably as good or better than what other people are doing. If you just Google Python, there's like 1,000 classes and boot camps,
Sure.
right? So yeah, so there's a lot of options.
And
Anyway.
thank you, Kiran. Thank you, Kiran, for introducing us to VJ.
Yeah, this course would not have happened without Kiran, by the way, because I designed the course, but I was not going to run it because I was busy with something else. And Kiran said, "No, we'll do something." Then I said, "Fine, I will just do it." So, and in the beginning, some things were unclear, so that's why I'm saying it was a experiment, because I didn't know everyone's level in Python, and then how
True.
Kiran already spent some earlier courses with me. So, but I think it worked out in the end. It worked out okay.
Yeah.
I covered a little less than I wanted to do, but I think we touched everything. What we touched, we covered in some detail, right? So that you understand the concepts. So I think that was a good achievement. So I would just encourage all of you, keep up the good work. It's really excellent, and I will be in touch by email. If you need anything, don't hesitate to ping me. Okay, just send me email. I will follow up.
Sure. Yeah.
Plan for some course.
Sorry, Kiran, one more time.
I said please plan for some course, like find the course next week. Because
Just
we are
one
going
more.
to start it. Yeah, we are going to start it from 15th July. So
Okay.
please have something in place, some draft.
Yes, I will. So let's do this way. No, we have a little bit of time. So let's do the following. At some point, either you will start it or I will start it. Let's do a small email thread and start talking about the kind of. I definitely want some good examples. Okay.
Yes.
So I'm just giving an example. We don't have to settle it right now. For example, if I say, okay, let's analyze some cricket data. Okay, for example, then you guys have to tell me that's interesting or it's not interesting, right? Same thing if I say to Pallavi, can you make some data set with Scrum data in it? Make even a fake, then what can we do with it, right? Same thing, Sachin, you said something, parsing a file. Can you find some example file, whatever, something. So we have to come up with good. I can make some, but at least I want to bounce it off of you, and then you tell me that's interesting or not. I think most of them are going to be interesting, okay? But still, if we pick the right things, we'll get more benefit out of it.
Yes, but I think it is like, when you see interesting data, you're able to convey it to us. So
Yes.
if you had shown me Titanic data just like that, I don't know if I would have found it interesting, or even Iris. When you talk about it, you are passionate about it, it just comes to us more easily, like we're able
Yeah.
to follow the data better and see it from your point of view. So
Exactly. No, I remember because I took a course like this online at some point, and the guy was doing Titanic dataset. I got very frustrated. Because I didn't know why they were using that dataset. He didn't explain the columns or anything to me. And the dataset had a lot of NAs in it. If you look in even now, right now, you'll see there are NAs in the dataset. So then you'll get all kinds of errors. Like I used to, in those days, I was not doing for loops, but I was doing a lot of things by hand. Okay, so every time I hit an NA, the whole thing will crash. So I will spend time, and then I'll try to remove the NAs, and I'll do all kinds of things. It was just very painful. So I felt I was not learning anything, but then I have to fix all these problems, otherwise I cannot make progress. And it was extremely frustrating for me, right? And that's what's out there generally, right? Stuff that's not clear. So then when I'm teaching you guys, I take care of all those problems, right? If I introduce a data set, I try to explain it. I show you how to handle the NAs if you need to, blah, blah, blah. And we make it into a part of our learning process. Then we can go faster.
Yeah.
But yes. So yeah, I will pick some data sets for sure and explain them to you as well. This iris problem, what did you think? Is it interesting to try to solve it?
it's nice, like
It's nice.
trying to the whole part of categorization. Once we learn it here, we can use it across different data sets where categorization or classification
Okay.
is needed.
Since you guys are so good, let me show you something cool here. 1 second. Give me 1 second. Okay, yeah. Okay, here's a little piece of code. Whoa. Iris data. Okay, I have to get iris data from somewhere. Isn't it called SNS? Sorry. This is for the next course, but anyway, I'll show you right now. Look at this.
Ah, oh my God. Now it like I can just say it without even running a program based on the petal and sepal sizes.
So a lot of cool things are possible.
Petal, right? This is
Yeah.
just the petal width.
Just the petal width, right? The only problem you can see that's clearly setosa is clearly separated, right? But the other two have overlap. So if you get some number like 5.0, you won't be able to tell.
Correct.
So then you have to use not only petal width, but petal length and sepal length and all that stuff.
Correct.
So a lot of cool things that can be done. I'm just showing you, look at how powerful these tools are, right? Just a couple of lines of code, I made a quick plot and boom. Now you can stare at the data for all the time you like. You never see this pattern. Right? So I just want to show you, it's like magic, but it's good magic. Hopefully it made you smile. And did it make you smile?
Yeah. Yes.
Yeah, it's very cool. The other day when I created this plot, I was like, whoa. First time, same thing happened to me. When I first saw the iris dataset, I was going crazy. It was in some data science course. I had no idea what he was trying to do. Right? And I was like, I don't even like botany that much, but now I really don't like it. But then afterwards, I understood everything, and now I'm like, okay, I actually like it. No, it's pretty good. So anyway, with that said, okay, I'm going to let you guys go. I'll follow up with a couple of things. Let's keep in touch. Keep up the good work. And we'll talk soon. And slowly start thinking about how you use it in your career and everything. Okay, so it's all good. Okay, talk soon. Send email.
Yeah,
All right,
sure.
Vijay.
Thanks a lot, Vijay. Thank you so much.
My pleasure.
All right. Bye, Vijay.
Bye, Kiran, Pallavi, Sachin. Bye.
Have a good weekend. Pallavi has got dropped off. She said that her batteries.
Okay, bye.
Okay. All right.
Okay, bye-bye.